Welcome to the Building Biology webinar on electromagnetic exposure. And this particular webinar is on electrical grounding system basics. Oh, what I gotta do in there? It is. Now it looks okay. You can't talk. Okay. Now today's lecture is one of the component lectures. If you would do this in order, there would be a different order, but this is one of the component ones. And so what this lecture, the body of this thing is on the location of the grounding. We get to do it a section. This issue is where which ones you should choose first, and then an overview of the purpose of grounding, and then the definition of basic grounding system components. Because normally the way you would start out is you would start out on this screen, and if you want to do some webinar on electromagnetics, then you could click on the word electromagnetics, or if you knew more details, you could go straight to it. And then if you clicked on electrical, then you would go to another menu. This is the practice screen, but then you would get to one that says electromagnetic exposure, and then you could click on radio frequency. You look at the spectrum, look at this, or you look at any of these things and light any one of these things, and click on any one of those would take you to another, taking hang on a second here. Since it's all practice, there's no
another page.
There's no wrong answer. Yeah, there's another page. But anyway, so I think we just need to have a separate webinar that goes through how this selection process works.
Mm-hmm.
All right, so anyway, so now we're going to go, and of course you don't ever want to use that word anyway. And now we go to the next one, and then, so now if you chose grounding, and then under grounding and system, there's grounding terminology, there's, how this affects electric and magnetic field wiring, and this is the one we're talking about today, which is the grounding systems basics. But if you go on wiring, then here's all the different components of the wiring system, and then each one of these will be a separate webinar. So, okay, now I gotta remember. Okay, so now this is when we talk about the word electrical grounding system, that refers to all the metal in your house. And so, and specifically, it's all the metal, the metal frames of all the devices, the metal boxes, the metal frame of your washer, your dryer, all that is part of what's called the grounding system. And so this is our diagram out in here. So all these metal boxes, all this is all part of the grounding system. And then also inside of the individual cables, all the ground wires inside the individual cables are all part of the grounding system. And then you want all the metal frames of the wash machine, the dryer, everything, that's all part of the grounding system. And the whole idea is if any hot wire touches any of that metal, then there's a low resistance path, so it'll blow a fuse, so there's something wrong because the fuse blew, not because you touched something and got a shock. And in order to discuss all these components in the system, then we have to have this understanding of the different terminology. So that's what we're going to talk about, is the terminology of the grounding systems. And under the grounding systems, then there are two components, or two categories in the grounding systems. And one is called the system ground, and one is called the equipment ground. And the difference is that the system ground just means that some part of the electrical or the system ground has a metal path that goes into physical dirt, which could be these ground rods. And then in the electric code book, they call ground rods is just an example of a grounding electrode, which is a physical piece of metal in the dirt. And so then the normal is to run a wire from this grounding bus in the main panel down into here, into these two rods in the dirt. And then they are and then they also run another wire out to the water pipe, which is now becomes a equipment ground, which you'll talk about in a second, for the water pipe system. But since the water pipe, if it's metal and goes into the dirt, it's now part of the system ground. So the purpose of the system ground is strictly to provide a path for surges such as lightning. So a system ground doesn't have anything to do with the tripping of circuit breakers. It's just strictly if there's a surge onto the electrical grounding system, that surge has a path to get into the earth. And if there's not an easy path, then the lightning will jump across some gap and cause a fire. So this is a fire prevention by lightning issue. And then the equipment ground is a whole different animal. The purpose of the equipment ground is if there is something wrong with the wiring within the building, then the equipment ground is supposed to trip the breaker before you do like our little blue avatar here and touch a device with a fault. And a fault here, the definition of the word fault just means that there's some connection between a hot wire and the metal frame of the device here, which in this case, I guess this is a microwave oven. And so then, if there was a hot between here and here, and this person had plugged this 3-pronged cord into a 2-pronged outlet, now there's no connection between this grounding system component, the frame of this device, and the start of the service. So now this whole metal frame is at 120 volts. And so it's just sitting there as 120 volt device sitting on your counter, and you don't know that you have a hot thing sitting on your thing there, because if you touch this frame, then you're at 120 volts. And if you're electrically sensitive, you would know that. But if you're not electrically sensitive, then you're just at 120 volts with respect to the earth. And then you reached over and simultaneously touched the stainless steel sink, which is connected to the plumbing system, which is grounded, then you would get the shock. So in order to avoid that whole issue, as you found out there was something wrong by getting a shock, if this ground wire is intact, then when this fault happens, then the circuit breaker just breaks. And now you go over there and you try to use the heater, the heater here, and the heater doesn't work because the circuit breaker is tripped. So you know there's something wrong because the circuit breaker tripped. So this is the basic difference between equipment ground and system ground, and we're going to refer to this when we're discussing all the other grounding issues. We're going to make lots of references to this issue of equipment ground versus system ground. Because one of the problems we run into is people, when they confuse the two, and so they have a piece of metal sitting there, and then they say, well, I'm going to ground that device. And they just run a wire and they stick it into the ground, and then they say, see, I grounded it. There's a wire between this metal frame and the earth. It's grounded. But that's a system ground, but it's not an equipment ground, because if this metal case is not connected to the building system ground, and then you just run a ground rod, then if a hot wire touches that frame is now at 120 volts. And you'll just have some electricity going down that rod, but the frame itself is still at 120 volts, so if you touch it, you get a shock. So that's the big problem we have with when people confuse these two and think if you drive in a ground rod that the device is grounded. It's not. That's just a system ground component, not an equipment ground. And so here's some other examples of this issue of grounds and system grounds is that, see, here is a transformer, and then the note is that we're gonna, well, let me go to the next one. I think it's before this one. I will, they're out of order here. Okay. This one. I want to go to this one first. So we erase the previous 30 seconds. And the point is here is to go, and now when we're given an example of discussing grounding systems, is that this is a diagram of the grounding systems. And then that's the general rule, is every time we show a diagram, there needs to be a picture. You know, this is a side note, as they say, just to fill up time, is there needs to be a colored picture of an actual one. So every time you show anything, you got to show a picture of what a real one actually looks like. And so then here is, and then in the world of electric codes, then ground wires, you know, or which is any wire that's connected to the grounding system, is they use the color green. And that's when you see the actual wire, it'll have a green coating on it. Or the other way you can have grounding systems is just a bare copper or aluminum wire. So if it's either a bare wire or a green wire, then that means that that wire is connected to the grounding system. And so here we have, and so then the other definition here is the definition of the first shutoff. And the definition of the first shutoff is wherever you have the switch that connects, wherever you have the switch, which is right after this electric meter, then that's called the first shutoff. But most houses come out of the meter and then go through wiring and then come over into here and into the main breaker. And now if this main breaker is where the first shutoff is, then there's only 3 wires from this meter over to here. If there's a shutoff all the way outside the house, then we have to have 4 wires, because neutral and ground, and there's a whole nother webinar in the definition of neutrals and ground. Well, maybe we'll get to that some today. But anyway, so this is an example of what a main panel looks like. This is kind of a crude version, because the main thing I was trying to illustrate with this particular drawing is this issue: if wires come into the panel and they're greatly separated inside the panel, then the panel itself gives off big magnetic fields. So that's why we don't like this particular configuration, you know, of showing separated wires. And then you see the ground wire continues here, goes all the way out to here. And then we have another wire. This is the wire, the conductor that goes from this ground bus. And the definition of a bus just means is some piece of metal that has a bunch of screws in it so you can connect multiple wires to a same point. And so in this case, this is a ground bus over here. This is a neutral bus. And so now we have a wire. Normally you have a wire that runs from here over here to the water pipe. And normally in the old days, then this was the equipment ground for the system, for the water pipes. And but then they also notice, well, then that same piece of pipe goes all the way out as metal in the dirt. So just like magic, we put on one wire, and now we've created a water pipe itself is an equipment ground, or isn't a system ground. So this single wire, most houses, or virtually all houses, only have one wire going over here that serves the function of being a system ground and being an equipment ground. All right, so now here's out the outlet, showing here's that third prong on the outlet. So then, all right, we already did, what did we go away? This guy here, then this is another example when we're talking about system grounds and equipment grounds, is that here's the transformer out here on the pole or sitting on the ground. If it's on the pole, it's called a pole-mounted transformer. If it's sitting on the ground, it's called a pad-mounted transformer. And that's the device that converts the 7,200 volts coming down the street to the 240 volts that's coming into your house. And this comes over to your house. Here's your main panel. And then here is, right, here's that wire. That's the combination equipment ground and system ground going over to the water pipe. And see, the water pipe is going into the physical dirt. So this particular wire here is a system ground and an equipment ground. This device, this wire here is the ground wire going out to any device, grounded device, such as a washing machine. And so that goes out, connects to the metal frame of the dryer. And then here is a pure system ground, because it's going from the grounding systems going out to a ground. Well, it's called in the electric code, they say this is going out as a grounding electrode. In this particular case, it's a ground rod. And so now if we follow the electricity coming in the hot, comes here's this is 120 volts, goes through here, and now once it gets past the load, now this is down in the low voltage, and then it goes in and it connects to here. So normally it should go back to the center of the transformer. But in the real world, current takes all available paths, and one path is to go down to here, go down here, go down here, into the dirt, over to here, come up the ground wire out on the pole and get back, or it could come out, go out here, go through the frame of the dryer, go down to the metal feet, because the dryer is sitting on the concrete, and concrete is a conductor, and it can go flow through the concrete into the dirt, from the dirt going over to here. And so what we're illustrating here is this issue in normal houses. There's current flow on all these metalwork in your house just because of the way the system is set up. And so ideally, if we want to minimize electromagnetic exposure issues, we have to eliminate all this current on the grounding system. Here's our large overview, and you're having way too much fun here. I'm running out of time, but good. And all right, so there it is, our practice run. Now I go into here and I stop